All right, here we go with 3.11. Remember, there's a quiz on learning target 3A, 3B, and 3C. Definitely study hard for this one. 3A is, of course, adding, subtracting, multiplying, dividing, and simplifying rational expressions. 3B is solving them. And 3C is writing and solving. All right, let's go ahead and take a look at one of those questions from the quiz last week to kind of prep us for some of the solving, and then we'll move on to some new writing of equations. So you'll remember this question. I need to solve for the speed of the boat, which is given by x. And this is very similar to an equation that we actually wrote a little while ago, where if you think about distance divided by speed, you're going to get the time it takes you to travel that far. And so if this were on the way there, this might be 2 miles on the way there. Your speed of your boat, maybe it's being pushed back by the current. So this is the time on the way there. On the way back, the current's helping you, so this is your time on the way back, and maybe overall it takes you 1 hour. So what we really want to do here is, of course, solve for x, but stay very organized. Okay? So what I realize is that, before I go over this, I want you to pause the video, and I want you to try this on your own again, and I want you to stay really organized. Do all of your scratch work somewhere else that's not going to get in the way of you moving in a logical flow through the question. Okay? Even if you get stuck, stop, think about what you need to do next in order to get one step closer to solving for x. And only once you've tried it a couple times do I want you to press play so we can go over it. All right, so I need to solve for x, and with that I need to get this x out of my denominator here in order to solve for it. And so the first thing I've got to do is notice, look, I have two rational expressions here. If I add them together, I'll end up with just one rational expression, and then I will have a much easier time solving for x. So I'm going to multiply to get a common denominator. And remember, I have to multiply by the same binomial on top and bottom so that I'm not changing my fraction here. It's just like I'm adding regular fractions. All right, so now on the left side of my equation, I'm going to have a common denominator. And my common denominator is going to be x minus 1 times x plus 1. And when I FOIL that out, I'm going to end up with x squared minus 1. Up top, I would have 2x, so I would FOIL this, right? 2 times x, 2 times 1, 2 times x, 2 times negative 1, and that will leave me with 4x. The positive 2 and the negative 2 are going to cancel out. And then I have 1 over here. Now I need to multiply on both sides by my denominator, x squared minus 1, x squared minus 1. And I guess I should have trying to color code here. Good. And so on the left side, I'm going to end up with 4x is equivalent to x squared minus 1. At this point, you're saying, okay, I need to solve for x. I have a quadratic over here. If I just move this over to the right side, I'm going to have a quadratic equation set equal to 0. So if I subtract 4x from both sides, I end up with that coveted situation where I just have a quadratic equation, x squared minus 4x minus 1, and I want to find the root of this quadratic equation. So I can use the quadratic formula to solve here for x. So I want to do this off to the side so that I can keep my space neat and ready to go. All right, so off to the side, I know that this equation will be solved when x is equal to negative b, which is negative 4, so that's positive 4, plus or minus the square root of b squared. B is negative 4, so b squared is 16, minus 4ac. A is 1, c is negative 1. So I'm going to have minus negative 4 all over 2 times 1, which is 2. So x is going to be equal to 4 plus or minus, and inside of my root I have 16 minus a negative 4, so that's going to be square root of 20 all divided by 2. I can simplify this a little more. X is going to be 4 divided by 2 is 2 plus or minus. Now the square root of 20, that's the square root of 5 times 4, right? 5 times 4 is 20. Well, that's the same as the square root of 5 times the square root of 4, which is the square root of 5 times 2. So I have 2 times the square root of 5 divided by 2. 2 over 2 is 1. So x is going to be 2 plus the square root of 5, or x is going to be 2 minus the square root of 5. Okay? Now the square root of 5, you can approximate that, and what you're going to find is that the square root of 5, if you think about it, the square root of 4 is 2, and the square root of 9 is 3, so it's somewhere in between 4 and 3, and it turns out the square root of 5 is approximately 2.23. So if I were to compute here, x is either going to be 2 plus 2.23, which is 4.23, or x is going to be 2 minus 2.23, which is negative 0.23. So those are my options, and I'm going to choose the positive version because I'm looking at the speed of a boat. And it wouldn't seem to make sense that the speed of my boat would be negative. Perhaps I were, backing up the whole time, and that could be the case, but in almost all situations, unless I'm specifically thinking about a boat going backwards, it is likely that I am traveling at a positive speed. So x is going to be equivalent to 4.23. That's the answer choice that I'm going to choose, which means that my boat is traveling at 4.23 miles per hour. So to help us build a better toolbox for creating equations, we want to identify another relationship. So you may remember that we discussed the relationship between distance, speed, and time, and how knowing the relationship between those three things can help you put together equations. And here's the next one. So what is the relationship between the rate at which someone works, R, the time at which for which they work, T, and the amount of work they accomplish, W? So pause the video, write this down. Now, I encourage you, whichever seems easiest. If you want to go straight and write an equation, or if you want to represent it in a sentence, whatever it is, just spend at least 2 minutes thinking about it and writing out the relationship. So hopefully you understood what the relationship is, and it should be clear once we use a little example. So let's say that the rate at which you work, and let's just say you're building tables. Okay, so let's say that your rate is that you build 2 tables per hour, and that you work for 7 hours. Well, how much work are you going to get done? Well, the amount of work that you get done, the number of tables you produce, is going to be the number of tables you produce per hour times the number of hours you work, or 14 tables. And so we can see the relationship, which is that the work you get done is equal to the rate at which you're working times the amount of time that you're spending on it. And so analogously, we know that the time which you spend on something is going to be the work that you get done divided by the rate. Or in other words, let's say that you create 14 tables, and I know that 14 tables, and I know that you can complete 2 tables per hour. How many hours did you work? Well, 14 divided by 2 per hour is going to give you the 7 hours. And then again, the last thing we can solve for is the rate. So the rate at which you work is the amount of work that you accomplish divided by the time that you spend. So having these in our back pocket are going to help us when we're dealing with situations where we're computing various things and we're thinking about how much work people are doing in certain amounts of time. Tamir can paint a room in 5 hours, and Roberto can paint a room in 3 hours. How long will it take them to paint a room if they work together? So pause the video and try this on your own. Make sure that you split your paper up either horizontally or vertically. And my advice here is to use words. Write a sentence that describes the relationship. And don't worry so much about whether you can plug variables in yet, but just make sure that your relationship makes sense. And then once it does, move from there into inputting and representing each piece of your sentence, your equation sentence, with variables. Okay, I hope that worked. So as we go through this, if there was a spot which all of a sudden allows you to, you feel like, okay, now I can move on my own, and you want to pause the video and really try to go on your own, because that when you're working on your own, that's how you're going to be making connections and be really learning. So make sure you're doing that. Okay. Couple of things that we obviously want to pay attention to. First off, the pieces of information we have about Tamir and Roberto. And then, of course, what we're looking for is how long it will take them to paint a room if they work together. So here I'm just going to say that my variable that I'm going to be looking for is t. It's going to be how long it will take them if they work together. And so now I want you to sort of just kind of, in your mind's eye, picture a room, and you have 2 people who are painting it simultaneously. And so how fast is it going to take them to paint this whole room? Well, if you think about, say, you're each starting on different sides of the room. What it depends on is how fast each one of them is painting, right? How much of each wall they paint per unit of time. And if you combine these 2 sides and sort of add them together, right, that's how long it's going to take them in total. So if I'm thinking about how I could represent this as a sentence, right, so the amount of the room that Tamir paints plus the amount of the room that Roberto paints, well, that's got to all add up to the number of rooms they paint, right? And in this case, it's 1. So if I'm creating a sentence here, if I'm thinking about a relationship that combines and that ends with them painting 1 room together, it's that, the amount of the room that Tamir paints, so I'm going to say, I'm just going to represent, I'm going to say the part that Tamir paints plus the amount of the room that Roberto paints, that's got to equal up to the number of rooms. Or in this case, I'm just going to write number of rooms. And in this case, that happens to be 1. So when I think about this, okay, this is going to end up being 1 room. So now we've got to think about how do I figure out how much of the room Tamir paints? Well, this amount that Tamir paints, this is really the amount of work that Tamir is doing. Okay, so I'm going to use colors here. So this is going to be really the work that Tamir does, and I'm going to add that to the work that Rob does, And when I combine these together, the total work that they do has got to be 1. Okay, and so this is just like we saw with time, right? The time of a trip on the way there plus the time on the way back, that equals the total amount of time. Okay, so if I think about it here, the work that Tamir does plus the work that Robert does is got to equal the total amount of work done. So this is the work in total. Okay, and this is going to be really helpful, right? If you know the people that are working, well, the work that each does has got to, when you combine them together, is the total work that's done. So now, hopefully, this is got you on the right track, because we just talked about how do you compute how much work someone does. So go ahead and pause the video now and try and complete your equation and solve. So we remember that work, the amount of work you get done, is equivalent to the rate at which you're working times the time at which you work. So the work that Tamir is going to get done is going to be the rate at which he's working multiplied by the time that he is spending. Well, we know the time he's spending, right? That's T. That's what we're trying to figure out. And we also know that he can paint a whole room in 5 hours. So what's the rate at which he works? Well, if I paint one room in 5 hours, then I'm going to be painting 1/5 of a room every hour, right? And I should say 1/5 of a room, or rooms per hour, RPH, rooms per hour, right? Think about it. He's working to paint a whole room in 5 hours, so each hour he's got to paint 1/5 of the room. So the work that Tamir is doing is going to be the rate at which he's working, which is 1/5 of a room per hour, times the time at which for which he works, which is T in this case. And the same is true for Roberto, the work that he does. Well, he can paint one room in 3 hours, so he paints at a rate of 1/3 of a room per hour. And then I multiply that by the amount of time which he works, and that will give me the total amount of room that he is painting. And of course, this has got to add up to 1. So now we're in business. Now we can actually go ahead and solve this here. So pause the video now and go ahead and solve it, and we'll check our answers in just a second. So there's a couple ways to solve this. One way is to say, okay, 1/5, 1/5 times T, well, that's T over 5. And then here you have 1/3 times T, which is T over 3, and you could add these together and you'd get one rational expression, and you could go from there. But I think the easier way is to notice that each of these terms has a T in common. So I can factor out the variable T, and when I factor that out, I'm going to be left with 1/5 plus 1/3, and that's got to be equal to 1. And let me use this same color here. Okay, so now I'm very close to solving. This in here, 1/5 plus 1/3, well, I can add that all together. And 1/5 plus 1/3, if I have a common denominator, make a common denominator here, so this will become 3/15, and this will become 5/15, and I'll add that all together. That's going to give me 8/15. So now I can solve for T, and the way that I can do this, right, is I can divide by 8/15, or multiply by the reciprocal, right? So I multiply by 15/8 on both sides. Okay? So over here, 15 over 15, 8 over 8, and I'm left with T is equal to 15/8. And what is 15/8? Well, that's going to be 1 7/8. So the time it's going to take them to paint the whole room together is 1 7/8 hours. Okay, I'll let you figure out. All right, use the rest of your time to get some practice for the quiz. Go back and redo some problems from the past. You can go back, watch some previous videos and try those problems out. I'm going to put one more problem up for you to try, and that will involve writing rational equations. So give that one a try as part of your practice, and we will talk about it on Wednesday. Okay, here's that last question. Give it a try, and remember to use those tips that we've talked about.